This is Mr. Liao, and this is section 5.3 of Math 1, Solving Systems by Elimination. So today we're going to learn the basics of how to solve systems of linear equations using the elimination method. On Monday, we'll learn how to do it by graphing. You graphed both equations on the same coordinate plane, saw where the lines intersected. That point of intersection was the solution. Yesterday, we learned about substitution, where if you solve one of the equations for y or x, you can take that value, plug it into the other equation, and you end up with one equation with one variable. And then once you solve for that variable, like x, you plug it into another equation and get what y is. Today we're going to use a third method called elimination. So here are the steps to elimination. First, you will need to multiply, if necessary, one or both equations by a constant, so at least one pair of like terms have the same or opposite coefficients. In other words, you want to get it so that if you add up the two equations, either the x's will disappear or the y's will disappear. Now, for today's examples, you won't have to do this step. They're already ready to go, so you won't have to multiply. We'll work on those tomorrow. Step 2 is to add or subtract the equations to eliminate one of the variables. I always prefer adding. It's always easier to multiply an equation by a negative number such that when you add, you make the variable go away. Fewer mistakes are made when adding compared to subtracting. 3, you will solve the resulting equation you get after you add the two equations. And 4, you will substitute the value that you got from step 3. So if you eliminated y, you would solve for x. You would take that value of x, plug it into one of the original equations to solve for y. If you eliminated x, in step 3 you would solve for y. You would take the value of y that you got, plug it back to one of the other equations, and solve for x. So here's example 1a, and I label the equations number 1 and 2. You don't have to. So the first equation is 3x plus 2y equals 4. 3x minus 2y equals negative 4. Now you will notice that there's a 2y and a negative 2y, and if you added them up, they would go away. And that's the idea of eliminate. You are going to eliminate the y. So I'm going to go through the 4 steps. For today's example, step 1 is already done. So notice that coefficients for y, the 2 and the negative 2, are already opposites. So you don't have to multiply either equation by a constant to make it such that the y's or the x's eliminate when you add. So step 2, you are going to add the equations you're going to solve for x. So if you add the equations, the 2y and the negative 2y will cancel out. So you have 3x plus 2y equals 4. You have 3x minus 2y equals negative 4. You're going to add the equation. So add the things on the left side together. Add the things on the right side together. So 3x plus 3x is 6x. 2y minus 2y is gone. 4 minus 4 is 0. So you get 6x equals 0. You will now divide both sides by x, and you see that x is equal to 0. So step 2, add the equation. Step 3, solve for one of the variables. Step 4, you're going to take the variable you got, plug it into either equation that you started with, and solve for the other variable. So you know that x is 0, so you're going to plug in 0 into either equation and solve for y. So let's use the first equation. 3 times 0 plus 2y equals 4. That 3 times 0 is gone. So you're left with 2y equals 4. Divide both sides by 2, and you get y equals 2. And remember, you should always express your answer as an ordered pair, 0, 2. All right, here's another example. Negative 2x plus 3y equals 4. 2x minus y equals negative 8. So you will notice again that you do not have to multiply any equation because the negative 2x and the 2x are opposites. So you can add up the equations and the x terms will go away. They'll be eliminated. So now we're going to add the two equations together. So you get negative 2x plus x, that's gone. 3y minus y becomes 2y. 4 minus 8 becomes negative 4. So you're going to add them up, and you divide both sides by 2, and you get that y equals negative 2. So you're going to plug in negative 2 into either equation and solve for x. So 2x minus negative 2, that should say solve for x. 2x minus y equals negative 8, so minus negative 2 equals negative 8. I'm using the second equation. So negative minus negative 2 becomes 2x plus 2 equals negative 8. Subtract 2 from both sides, you get 2x equals negative 10. Divide both sides by 2, you get x is negative 5. So again, you write your answer as an ordered pair, negative 5, negative 2. So today, all you're going to do with these examples is add equations together. One of the variables will be eliminated, solve for the variable that remains, and then you're going to go back, plug that value into either equation to solve for the other variable. Don't forget to write your answer as an ordered pair. Here's your assignment that's due today. It's not due tomorrow. It's due today. Page 233, 3 to 9 odds, 36 to 41 all.